Hello everyone, welcome to my presentation. I am Sankari. My registration number is 17BEC0118 and my class roll number is 04. I belong to the slot A2 plus Da2. This is my digital assignment 1 presentation. First of all, I would like to thank my professor, Mr. Da1 sir, for making all the concepts very clear in the class and for giving me the liberty to choose a microcontroller and learn about it myself through this DA. So the microcontroller that I chose is 8088SC0104CA microcontroller at MEL. Moving on to the questions. The first question is, draw the clear block diagram of microcontroller microprocessor IP core selected. So that the diagram here, I got this from the datasheet that I downloaded for my microcontroller, and I drew this diagram with the help of this software called Da1 It is basically a website where you can just go and choose the shapes that you want and align accordingly to get the diagram that you require. It is a very versatile and easy to use software, and it basically takes a few minutes to do the diagram that I've done here. And yeah, it does take a lot of practice. In the beginning it might be very hard, but once you have acquired an optimal amount of practice, everything is very easily done with that software. Moving on to the next question. Give the internal diagram of each and every block. I have given the internal diagram of EEPROM here, this part. So I was not able to find this in my data sheet, but I found this online. So again, I do this diagram with the help of Da1 A2. So moving on to the second question, provide the instruction set of the microprocessing element with clock cycle required, machine cycle required, memory required, flags affected, type of instructions based on addressing mode, operation, etc. So here I have made a tabulation of all the important instruction sets that I gathered from the instruction set manual of this microcontroller. As you can see, I did this in Microsoft Word. And memory required, flag, addressing modes are clearly explained. Going to the next question. Explain microprocessing element, microprocessor or microcontroller or IP core architecture. So the architecture that was used here is AVR32, which is basically a subpart of AVR32 UC CPU. And I have given a summary of the programming mode instruction set and NPU of this architecture. And we can learn more about this architecture in its technical reference manual if interested. So about this architecture, it is a new high-performing 32-bit RISC architecture. This architecture was designed for cost-sensitive embedded application with particular emphasis on low power consumption and high core density. All of these are clearly given. explained here. Different functions and descriptions are explained as well. In the diagram here, I drew this with the help of draw.io again. So the fourth question is, correlate the microprocessing elements architecture with architectures discussed in Module 1 and Module 2. General depiction of the von Neumann system is discussed, and actually how the control unit fetches the next instruction from the memory program counter, and data operands are then fetched from the memory and are placed in the register within the CPU, and the instructions are then converted into ALU understandable language, and those are executed. So this process is discussed, and the correlation between the different architectures are discussed here. Moving on to the next question. Elaborate register organization of microprocessing element. So here the register file is organized as 16 32-bit registers, and these registers include the usual program counter, the link register, and the stack pointer. There is also a register called R12, which is designed to hold the return values from function calls. There are also different registers like user visible register, system register, and how the event handling in AVR32 UC is done with the help of a stack pointer is discussed thoroughly. And in the next question, explain the type of algorithm used for signed or unsigned calculation. In this question, different calculations are discussed, where MUL is basically multiplication of unsigned integers, MULS is multiplication of signed integers, MULSU is multiplication between a signed and an unsigned integer, FMUL is multiplication of unsigned fractional numbers, FMULS is multiplication of signed fractional numbers, and FMULSU is multiplication of signed fractional numbers with unsigned fractional numbers. And coming to addition algorithm, BCD and binary algorithms are discussed, and that's what was basically done in this microcontroller. So to the next question, find what type of control logic unit used and correlate its performance with the type of control unit in module 3 in COA syllabus. So basically there is fetch instruction, interpret instruction, and then there is fetch data, there is process data, there is logic data, where basically the CPU reads the instruction from the memory, and the interpret instructions where the instruction has to be converted or decoded to the ALU understandable language, and then fetch data is where the execution of instructions, we know that execution of instructions may require the data, so those data are then fetched from the memory or IO module when an input of data is given. So then there is process data where the execution of instruction requires some arithmetic or logical operation on the data, and the execution, that is the output of this, are then returned to the memory or in the output module, that is write data. And so some other conditional codes and logic control logic units are also explained here. Going to the next question. So moving on to the 8th question. Explain the memory management system and the processing element selected. List its addressing capabilities, memory mapping techniques allowed, Find the advantage of memory design and management techniques over the concepts given in Module 4 in COA syllabus. So here the memory consists of memory which is private to each core, and an interface which is private to each core, and an access which is basically which is an interface that connects to each of the core. Here, if you see this diagram, I drew this diagram again with the help of Da1 A2. As you can see, so here the core has independent path to access instructions and data. The data side reads and writes data, and the instruction side fetches instruction. The TCM interface here provides fast access memory, and it holds instruction and data. It actually has three masters, master A, B, and C, and all of its functions are detailedly explained below. So moving on to the next question. Elaborate the pipeline and parallel processing capabilities of unit and hazard management techniques. So the pipeline design is actually a 2 superscalar design. It actually gives a very high instruction throughput and efficiency. When you take the instruction execution, if it is an integer, it is actually a 4-step stage. First one starting with the issue, execute 1, then execute 2, and then write instruction. And if it is a floating point or an advanced SIMD instruction, it has 6 stages, starting from issue, floating point 1, floating point 2, floating point 3, floating point 4, and floating point 5. All these instructions and parallel instruction executions are detailedly explained, and hazard management is explained thoroughly as asked in the question. This is the last question where process level parallelism is explained in detail. This is the end of the presentation. Thank you very much if you listen to the presentation till the end. Have a good day.